Hi, I'm Charles Hoskinson, Chief Executive Officer of Input Output, and I'm here today to talk about the fourth generation of cryptocurrencies and one of the best products we've ever built in the history of my company. So back in the olden days, before the earth cooled, we had good old Bitcoin. And Bitcoin was a really magical thing. It took a long time to get to it, all the way up to 2009. And Bitcoin was really the first generation of the cryptocurrency space. And many of you who've heard me speak throughout the last decade will know how I talk about the generations. But really the problem that Bitcoin was trying to solve was this concept of decentralized value transfer. So when we look at decentralized value transfer in a digital medium, it was always possible to move value from one bank to another bank, one person to another person, but you always had a middleman that lived in between the people. And the problem with a middleman is that the middleman gets the power of the market. They get to see everything, they get to know everything, they get to decide the fees, they get to decide what to charge, they get to decide who gets to play the game. So what Satoshi Nakamoto was very interested in is, could we create some sort of instrument of value, in this case a Bitcoin, and can we create some sort of network that can transmit the Bitcoin to another actor? And it turned out that this was an unsolved problem, to do it in a completely decentralized, permissionless way. And nobody really believed that Bitcoin was going to be a thing until approximately 2013. Bitcoin kind of floundered in the beginning. Not a lot of participants, not a lot of value, but there were some very loyal adherents like the Hal Finneys and the Marty Malmys and the Mike Hearns and the Gavin Andresens and the Roger Vers, who carried the torch and the flag, and they were able to get us to an inflection point in the history. So we went from first generation to $0 to $250 Bitcoin. Then around 2013, something very special happened. People realized that this concept of decentralized value transfer was going to be a thing. It's here forever. So then they asked a very natural question of, what do we do with it? What do we do? And they said, well, transactions and value, they're fundamentally unpredictable things. What instruments of value? Stocks, bonds, commodities, currencies, intellectual property. There are thousands of different ways that you can represent value. And for transactions, there's potentially an unlimited amount of ways that you can express conditions of commerce. When you take a look at transactions, you say, well, there's one-to-one, person-to-person, Alice to Bob. There's one-to-many, Bob to a whole country. There's many-to-one, whole country to Bob, for example, many-to-many. When you look at transactions, you also have this concept of metadata around it. Good old metadata. The who, what, when, where, how, why. Where did you withdraw the money? When did you withdraw the money? You know, the geography that the money is based in. So you have geography. You have regulations. You have so many different considerations in addition to just the instruments of value that factor into transactions. So how can a fixed function system that only really moves Bitcoin in a very particular way ever hope to capture this entire universe of value that we have? Well, the idea of the smart contract came in. And this is very similar to when JavaScript came to the web browser. Before JavaScript, web browsers displayed static websites. They could be very pretty, they could be very interesting, but they were static fundamentally. Then JavaScript comes, and then suddenly we have this dynamicism, and we get Amazon, and we get Facebook, and we get YouTube, and all these magical experiences. So similarly, when we look at the dawn of the second generation, smart contracts became a big thing. And this was most notably the dawn of Ethereum. But what we noticed right around 2015, as the paradigm started developing, is we noticed that while decentralized value transfer is great and having programmability is awesome, this cannot work for large groups of people unless you had three properties. One was scalability. Two was interoperability. And three is governance. So 8 years ago, I did a whiteboard video just like this one. And I talked about how this was going to work its way through back in 2017 at the dawn of Cardano. And since that time, 8 years later, trillions of dollars of value has been created. Cardano reached a market cap at its all-time high of 100 billion, still it sits at 20. And there are now 550 million people in the cryptocurrency ecosystem. Concepts like the blockchain trilemma were introduced to discuss scalability in a responsible way. Enormous work has been done on the interoperability side. And on governance, we have now complete on-chain protocols for things. When we look at Cardano, we're actually one of the world's largest DAOs. When we look at Cardano, we actually, with Ouroboros Leos and Hydra, have really solved the blockchain trilemma in terms of scalability. And these technologies are coming online either now or in 2026. And when we look at interoperability, a lot of amazing progress has been made with respect to bridging infrastructure, but also a lot of discussion of interoperability into the legacy financial world, up to including new laws that are being passed. So it's a very natural question to ask. Are we done? Do we have enough? Because at the end of the day, the entire point of all of these generations is to run the world's economic, political, and social systems. It's to take nation states and companies, to take your personal finances and run it in a blockchain, run it in a completely decentralized way. Because each step of the way, it preserves some fundamental values. From Bitcoin on, for real cryptocurrencies, no one's in control. No one can freeze your money. Nobody has access to your funds unless you give it to them. You own your own identity. You own your own personhood. You have economic agency. And the answer is no. So that's what we're going to talk about here today. The final generation, the last generation before we bring the billions of people in, unify the financial markets, and bring the entire world to the cryptocurrency space. It's been an amazing 16 years to watch Bitcoin evolve into concepts like Ethereum and concepts like Cardano. And it's been the privilege of my entire career to be here since 2010 and to watch all of these things for the past 15 years. But I'm most excited about midnight. And the reason being is midnight is what makes crypto real for everyone. The fourth generation. Let's talk about midnight. So for the past 6 years, we've been in deep research and development, and we're trying to figure out how to solve the last three problems of the cryptocurrency space. The first problem is this concept of rational privacy. Second problem is the problem of identity. And the third problem is the issue of cooperation. They're all very different. Some are technology, some are social. But at the end of the day, we don't have a good protocol for managing all of this for everyone everywhere. Midnight seeks to be a layer 2 to everybody. See, the magic of Cardano and Ethereum and Bitcoin is that they were petri dishes to discuss all kinds of concepts, to discuss concepts of decentralized value transfer, what makes good value, and inflationary versus deflationary monetary policy. When you looked at Ethereum, it was a giant computational engine. It was asking, what should the digital oil of the world look like? And when you look at Cardano, we have made amazing strides when we talk about protocol upgradability. We've done seamless hard forks for 8 years. We've been running it 24 hours a day, 7 days a week for 8 years straight. And we've been able to create one of the world's largest DAOs. In fact, the on-chain treasury is over $1 billion. Despite all of this, when we look at these three categories, the category of privacy, the category of identity, and the category of cooperation, no one's really cracked these things yet. And the combination of the three is what makes the fourth generation come. And it's going to bring the remaining billions of people into cryptocurrency space. So let's start with rational privacy. We'll work our way forward, just like I did 8 years ago. So first off, everything in the world, whether you're running a Boy Scout troop or a nation state, has a public side and a private side. The blockchain space notably has maximized the utility of the public side. Every blockchain, if it's a real blockchain, typically is transparent, it's auditable, it's time-stamped, and it's irreversible, it's immutable. When you put something in, can't get rid of it, you know when it came in, everybody can see it, and everybody can verify it, inclusive accountability. These are amazing properties because the vast majority of economic, political, and social systems in the world don't have these. You can't check your own vote. You can't verify that the money in the bank's actually in the bank. You just have to trust a trusted third party. And unfortunately, most of the crimes of the world, the economic crimes of the world and political crimes of the world, take advantage of one of these things. The mafia cooks the books. They prevent you from being able to check things. Nobody can see the same state of the system. Somebody front runs and trades against you because they get to see something before you do. The problem is that most business also has a private side. You don't necessarily want the entire world to see everything you've ever bought. Your Amazon shopping cart, your Google searches. You don't necessarily want the entire world to see what's on Google Maps and where you've gone. You don't necessarily want the entire world to see your medical records or your academic records. You don't necessarily want the entire world to see sensitive litigation or other such things. Every single thing in life, like yin and yang, has a private side and a public side. The space is not complete if all we have is public with a little bit of private. We need the other half of the industry. The problem is, what does rational mean? Because privacy is not an absolute state. Privacy is a state where you disclose to some but not all. So my medical records, I don't really want the world to see them, but I'd like my doctor to see them. The academic transcripts, don't want the world to see them, but if I'm applying for grad school or for law school or medical school, they need to see them. Every single thing, you're always asking a question, private to whom? Who gets to see it? And the challenge is that all of the schemes so far that have been developed in the blockchain industry, what they typically do is they augment a blockchain with some concept of a trusted infrastructure. Okay, so they have an idea of a multi-party computation or multi-sig or some trusted execution environment. Or if it's on the blockchain itself, it's traditionally transactional privacy. So it's basically back to Bitcoin. You can send value from Alice to Bob and nobody can track it, and you probably can integrate into it some sort of disclosure key, but all you're really doing is moving assets around. But that's 2009, that's the first generation. So rational privacy requires a disclosure capability, but it also requires smart contracts. So we spent 6 years and we created an amazing technology called Kachina. And what Kachina allowed us to do is to take all the advancements that have occurred in the zero-knowledge cryptography space, really magical stuff that's absolutely incredible, and build a stack where you can sort out what's public and what's private, and then you can decide how to represent that private and prove it to the rest of the world. You can prove you know the recipe of Coca-Cola without revealing it to people, and when people drink it, they'll know it's Coke, but you don't have to tell them. You can prove that you are who you say you are. You're a U.S. resident, U.S. citizen. You can prove that you've paid your taxes. You can prove that you meet the compliance criteria without revealing the underlying information, this concept of provability. That alone is a massive innovation. That alone is something that's very special. But that's not good enough in a world which has so many pet technologies, privacy-enhancing technologies. What you have to do if you have rational privacy is you have to unify the entire world together. You have to think in terms of unification. You should not differentiate the blockchain from the off-chain. Typically in the blockchain space, we say, oh, it's on-chain, it's on the chain. Or no, it's off-chain, it's off the chain, somewhere else. This should all be the same. Your infrastructure is one thing. Privacy, every part of privacy has to work together as one system in order for it to be known. Otherwise, what ends up happening is it's private here but not here, and then the person over here leaks it. You can never guarantee that you have actual functional privacy. So you have to unify the entire stack. So we thought a lot about how do we do this in a way that captures where hardware is going, where the world is going. So one of the things that makes Kachina so special is we have a companion technology called Nightstream that we're working on with Midnight. And what Nightstream does is it looks to the next generation so far beyond where cryptography is currently at. So currently we're on Plonk and Halo 2. That's what we launch with. And that's awesome. These are wonderful words, wonderful technologies. Who cares how they work? But the problem with these things is they live in a different world. They live in a world without quantum computers, and they live in a world where all the privacy-enhancing technologies are fragmented. So with Nightstream, we said we have three goals. One is unify privacy. So pick a cryptographic primitive where the off-chain stuff and the on-chain stuff and the things we outsource all works together into one framework. And here we're using a very specific type of technology called lattices, lattice-based cryptography, which is also immune to quantum computers. It's very special and it allows you to do folding, recursion, and all these amazing things for infinite scalability. But two, zero-knowledge cryptography, this side of privacy, is very computationally expensive. It's very computationally heavy. So how do you have a compute grid that can deal with all of that if you outsource it to the off-chain side and somebody else does it instead of your cell phone? Well, we look to the future of hardware, and I have something special to show you guys. This right here is an NVIDIA DGX. NVIDIA is a $5 trillion company as of the time I'm shooting this video. And this little device here is about $4,000 and has over a petaflop of power. This small box is more powerful than every computer built by humanity up to 1991. A petaflop. Every few years, these things double. AI is creating an exponential surge in compute power like we've never seen in human history, and petaflops will turn to exaflops and yotaflops and beyond. And your phone is getting this, your laptop is getting this, your desktop computer is getting this. Computation is getting very cheap. The problem is that the math that these run on is not the same as the math that we currently use in the industry for this, which is a shame. It would be like saying Tesla can't enjoy all the advancements in battery technology that come from Samsung and Apple and these other companies. There's no reason to segregate these two things. And so we thought, and we said, let's innovate and create a heart of Midnight using something called tensor codes. And this will allow us to use the same mathematics of CUDA and other things that come from NVIDIA and AMD and these companies to use GPU acceleration so we can linearly scale. So as NVIDIA continues to innovate, as Intel continues to innovate, as Apple does and ARM does, all of these wonderful companies, this will keep us future-proof and allow us to linearly scale. What does this mean? It means that when we talk about unification of the on-chain and off-chain, you can have a layer for acceleration, and you can use privacy-enhancing technology like MPC and TEE, especially simulation virtualization-based trust execution. You can have that combined with the on-chain mechanism of Kachina. Putting these two pieces together, we can linearly scale. And what that means is that more GPUs, faster the proofs get. So instead of taking hours or minutes, they take seconds, then milliseconds, and then nanoseconds. Organically gets faster for free. No ASICs, no specialized hardware, or any of these other things. And finally, when we look at unifying all the privacy systems and getting tensor codes, there's also a very natural question of what do we do with the data? So things that go on a blockchain, it's not a database. It's not like you put your entire transaction history of everything you've ever bought or all the places you've gone. It's a place for proofs. It's a place when somebody shows up and says, I know the recipe, you can verify it's right or wrong. It's a place when somebody says, this money I have is legitimate, you can verify it's right or wrong. It's a place when somebody says, I voted for this candidate, you can prove that. But it doesn't have the total voting history. It has to live somewhere else. And if we're talking about unification of privacy, we need a companion technology that gives us the ability to operate on encrypted data without ever decrypting it. And it turns out that there's a way to do this called fully homomorphic encryption. This was invented in the late 2000s by Craig Gentry and Dan Bonnet, and it was conceived of in the 1970s and 80s by the founders of RSA. So this is something that's existed for a very long time, but it turns out lattices are the same mathematics of the math of FHE, and there's a way to combine these things together. Tensor codes, FHE, and unified privacy. That's what Nightstream is about. It's a Linux Foundation decentralized trust project that we formed with partners, and this forms the heart of the aspirations of Midnight. So Midnight will launch with elliptic curves, Plonk and Halo 2, and then over time, it will migrate to a post-quantum scheme that takes advantage of the GPUs in your phone and beyond, that also unifies off-chain computation with multi-party computation. And then that means we have one unified privacy-enhancing technology ecosystem that's very easy to build on, very easy to modify, and built with the pride and skill of input-output and all of its partners. This alone is a massive innovation, especially given the fact that we decided to create a programming language called Compact, and that language looks a lot like JavaScript. It was based on TypeScript, which is a variant of JavaScript that tens of millions of developers know how to use, and you will be able to use this language to write all these contracts the way you want them, how you want them, where you want them, and they're going to run cheaper and cheaper and cheaper over time, and eventually they're going to allow you to manipulate your data and your databases. So we'll build adapters to all these. So this is rational privacy in a nutshell. It's privacy that links the on-chain and the off-chain, and it's privacy that gives you the ability to disclose to the people that you care to disclose to. The challenge, though, is with disclosure, and this brings us to the second pillar, it's identity. We kind of sort of have to know who people are. We kind of sort of have to know if you're allowed to see the information or not. Again, when you think about these systems, they're only as strong as the weakest link, and if you do all the blockchain stuff and the asset stuff and the transaction stuff with just smart contracts and no notion of identity, then the minute that you have to identify people, a trusted third party will sneak their way in and they end up controlling the entire ecosystem. We think about this a lot when we talk about algorithmic regulation. We talk about the DeFi ecosystem. So lately we've been working on the Clarity Act, and there's this question of how do you regulate DeFi? Right now, the older regulators, they say, oh, it's very simple. There'll be some centralized organization that stands in for the protocol, and they'll register as a bank and get licenses, and everybody who uses it has to go through know your customer and anti-money laundering and anti-terrorist financing, and as long as they get permission from that centralized actor, then they can use the decentralized protocol. Okay, I guess we're done, all right. No, that's wrong. It's so wrong. It defeats the entire purpose of everything that we've done, everything that we do. We cannot allow the vampires back in. We almost got rid of them. Buy some garlic, damn it. It's about time that we have a new paradigm. We have a new way of approaching this. And the new way of approaching this is a blockchain-based identity and disclosure system. And you'll notice that this fits hand in glove with the concept of rational privacy. They're like peanut butter and jelly. They come together. So for the past 10 plus years, an enormous amount of work has been done to create a new standard called the DID, the Decentralized Identifier, from the W3C, the organization that standardizes many things in the internet, like HTML and CSS and so forth. Well, the DID is this lovely little identifier, and you have a DID and a DID document. It's almost like a web address to an HTML body. So basically this is where you go, and this is the description of the thing. Well, this standard is completely interoperable with the blockchain industry. And a whole house of technologies has been constructed with the DID to be a universal identifier, an identifier for everyone. And it doesn't matter if you're a bot, an AI agent. It doesn't matter if you're a drone. It doesn't matter if you're a humanoid robot, like one of those Tesla bots. It doesn't matter if you're a human. It doesn't matter if you're a dog with one of those microchips. It doesn't matter if you're a bar of gold. When I say universal, I say universal identifier. The DID can actually represent all of these things, create accurate descriptions on all of these things. But the problem is, if you put a DID in a DID document naively on a blockchain or associate it with a blockchain, everybody in the entire world gets to see it because it's transparent, it's auditable. It's kind of the point of a blockchain. And it's irreversible. So you can't take it off once it's there. So everybody will know you're a dog. Sorry, Wolfie. So what do we have to do? We have to add rational privacy to this. And what's really cool is there's a whole host of amazing protocols like anon-creds, anonymous credentials, and dozens of other things that have been developed within the DID space that can be seamlessly integrated into a smart contract. And when you put these two pieces together, what you have effectively done is create an identity layer for the internet with privacy, where you're in the driver's seat. You get to decide. And this is a truly extraordinary thing. It's never been done before. Many years ago, I invited Vint Cerf. He and Bob Kahn created the internet to one of my conferences, and I had a panel with him and one of his former students who works for us, Phil Wadler. And I asked Vint one question. The question was, if you could do the internet over again, what would you do differently? He spent about 45 minutes describing it, but one of the things that he lamented was there was no identity standard for the internet, which added enormous amounts of complexity. This is why you have usernames and passwords, and this is why e-commerce fraud happens all the time and identity theft happens all the time. But on the other hand, without privacy, you create a dystopian hellscape where everything you do, think, and feel is tracked forever by a small group of companies and governments. So in hindsight, it's probably good that Vint didn't add it, but we kind of need it as we move into the 21st century. So we need it with privacy. Keeping the principles of Bitcoin, decentralization and resilience, privacy where you're in control of the disclosure regime. So when you combine these two concepts together, the DID and all the frameworks above them, with a unified stack for off-chain and on-chain, then what you basically do is create a system end-to-end where regulation can be automated. Settlement becomes compliance. So here's an example. Let's say you have Uniswap. It's a very large DEX with lots of liquidity. Now, I'm willing to wager that Uniswap would get very excited to have tens of billions of dollars worth of real-world assets on the chain. Stocks, real estate, insurance products, all kinds of things. They get very excited about this prospect. But if the real-world assets have a compliance regime, meaning maybe Americans aren't allowed to buy them, or Americans can buy the ones but they can't pay a yield, or they have to be an accredited investor, or you have to blacklist a jurisdiction like Iran, how can they trade on Uniswap? There are two options. Either Uniswap has to go and build that centralized off-chain company and basically decide who gets a special token to participate, or they just have to not be in compliance and the founders of Uniswap get dragged into a courtroom and arrested for some violation somewhere. Not really appealing either side. But what if you had rational privacy? Then what you would be able to do is you would be able to have two workflows through your transaction flow. You would have normal Uniswap, and then you'd have regulated Uniswap. So, normal Uniswap, you have an address, you deposit, you're good to go. Check. But regulated Uniswap, well, you have an extra step. you send to a pending address, and this triggers a call to Midnight. Midnight, as a network, because there's rational privacy, processes your DID and all these other things, and then it returns check, you're good to go, and settles. From Uniswap's perspective, it's one flow versus another flow, but all the mechanics are exactly the same. What happened is Midnight, as a network, acted as a layer to handle the algorithmic regulation for everybody. This is pretty magical because this is a reusable flow for pretty much any regulated commerce in the entire world, any jurisdiction, and you can have a choose your own adventure based on the geography of the user. It can be in Abu Dhabi or it can be in Germany or Japan. It doesn't particularly matter. And you could have radically different flows for what disclosure and proofs have to be, but no additional information went to Uniswap other than clearance from the network, a proof from the network. And you get a math-based guarantee that your privacy has been preserved along the way. Full automation. You also can automate regulatory schemas. Some jurisdictions, for example, charge a per transaction tax on Bitcoin and cryptocurrency transactions. India, for example, it's 1%. You could automate that entire schema, embed it within Midnight as one thing, and the user has absolute certainty that nobody knows who they actually are, and they have absolute certainty that their funds are in full compliance with whatever they're buying. And the operator of the DEX, they just add a little room in there, and they use Midnight. That's really the magic when it comes together. The same for medical records. You think about brokering these types of things. You have this federated cluster of different medical record databases floating around. You have your dental clinic, you have your optometrist, you have your hospital, you have your primary care physician, and all of these have a different view of who you are. Who you are is the aggregate of all of these things, and they tend not to sync with each other, especially in the United States. So how do we coordinate, especially when you get sick in Bermuda, get some food poisoning? You have to go to the hospital there. How do they get your medical records for all these various things? How do they know you just had a root canal? How do they know your eyesight's bad? How do they know that you have a weird allergy to stuff? They don't. So this is a coordination problem where the actors don't really trust each other. They don't know each other, but somehow they have to work together for your greater good. It's very similar, actually, in the financial flow between normal Uniswap and regulated Uniswap. So when you have rational privacy, this is actually a very useful thing to do, because then you can use Midnight as the coordination layer, and it can broker the movement of the medical records between the various people. It's very powerful. It's very exciting. Let's give one more example. And this one is going to be $1 trillion business, and it's going to disrupt Google and Facebook and Amazon and many other companies. Let's talk about our good friend, agents. We are here in the dawn of AI. ChatGPT 5.1 just got released today. Pretty exciting. We're in the dawn of agents. And there's this concept of agentic commerce. So recently, I went down to the Amazon, old Charles Hoskins, and I decided to do the Tukandera, a bull and ant ritual. And I wanted to buy a hat, a jungle hat. Now, this was actually a very important business decision. You know, I'm going to spend 10 days in the Amazon. Once you're there, you're there. You're not going to be able to do anything. You're on the Amazon River, sailing along. If I buy the wrong hat, it doesn't feel good, it's not comfortable, it's too hot, doesn't protect me from the sun, the insects can get in, I'm going to have a miserable 10 days in that jungle. So I spent more time than I care to admit researching and becoming an expert on jungle hats, and I actually just gave up and bought 10 hats, brought them with me. Because that's what you do when you go to the Amazon. That's how commerce works today. And now, for the rest of time on Facebook, on Google, other places, I get ads for jungle hats. Because that's how advertising works. When someone has expressed an interest, these companies get a creepy amount of data about you, and then they just start micro-targeting you, and they figure you have a hat fetish, and there you go. Facebook ads can be very revealing. But that's not how commerce is going to work in the future. So let's look to the world of 2030. You're not going to do a Google search. You're not going to go to Amazon. You're not going to go to review sites. You're going to tell an artificial intelligence, an agent, I want to buy a hat. And it's going to say, what do you want to do with that hat? Where are you going? What's the point? What's your budget? It's going to ask you a game of questions. I want ... And then it's going to have questions all the way down. And after it asks enough questions, it's going to say, I got it, boss. And it's going to go off into the web. And you have the human web, the safe human place. And then you have the bot web, which will be significantly larger than the human web. It's where the totality of all transactions, information, commerce is going to be held. The human web will shrink and shrink. In fact, more than half the traffic on the internet now is non-human. It's artificial. And by 2030, the majority of all traffic, super majority of all traffic, will be from agents. It'll go into the creepy, difficult bot web. And it's going to go look around, and it's going to come back. And it's going to say, congratulations, Charles, I found your hat. Yes. And actually, it might even just buy it for you if it has the budget. In fact, Coinbase and Google created something called the X.402 standard, specifically to this end, a payment protocol for agents. And this agentic commerce, this agentic searching of you tell it what you want and it comes back with the solution to that problem, will be the dominant pattern of searches and commerce by 2030. Well, here's two problems. Number one, how does advertising work in this model? Under this old model, I see ads on my social media pages. When I search, some of the results have ads in them. But it's not a human being you're advertising to anymore. You're advertising to a robot, an agent. And the second problem is that agents are only effective if they know you. The more they know, the better job they can do in serving your needs. But here's the problem. Do you want to turn over to this agent looking for your hat all your medical information? Do you want to turn over to this agent looking for your hat your net wealth? Do you want to turn over to this agent looking for the hat your address? All these types of things. Maybe, maybe not. But remember, when you do, it's there forever. And they'll never give it back. It goes to creepy old Sam Altman. It goes to good old Google. Sundar Pichai has it now. And there's not a lot of regulation about what they do with it and how you're treated with it, and not a lot of regulation of where they can sell that to. It's a multi-trillion-dollar market, and it's what a dystopian hellscape of privacy. So what if we can give the agents intuition, what you like, what you want, without giving them the underlying data? That is rational privacy in a nutshell. That is something so magical. And what if you could create a marketplace of agents that are custom tuned for specific demands? So when I was a kid, I used to walk to King Soopers. It was a supermarket here in Colorado. And walk by the magazine aisle, and you see all the different magazines. You have Consumer Reports and PC Gamer and all this other stuff. So my mom wanted to buy a new car, and I bought one of the Consumer Reports magazines. You flip through, and it has all the cars inside of it, and their ratings and all these types of things. The Consumer Reports of the future are going to be tuned agents, subject matter expert agents. So I would pay, because I spent hours and hours and hours looking for that hat, $3 on an agent marketplace for the hat agent that knows every single thing a human being could ever know about hats and represent my interests in buying a proper hat. I would pay for that. So I need a marketplace. And that is the magic of blockchains. They bring people together. They keep these cooperative things where you can tune and parameterize an agent. The person who's tuned the agent doesn't have to reveal the underlying data that made it because he has rational privacy. And the person using the agent doesn't actually have to reveal who he is or all these other things. But somehow, some way, the agent just auto-magically figures out how to do all of this stuff. And by the way, the privacy layer and the AI layer use the same computational medium. They both use GPUs. So everything runs in one big mesh. And this is the kind of world that Midnight is creating for people. This is the world of rational privacy. This is the world of selective disclosure. This is the world of new identity. And the agent has the same identifier that you do. So when you enter in, you can't differentiate between the humans and the bots, and that's good for your anonymity because you don't want people to know who you are, except for the times you do. Always speak in tautologies because you're never wrong except for the times you are. So this is rational privacy. This is identity. Are we done? No. Because the single most important question for any new project, any new protocol, any new endeavor is adoption. This doesn't mean anything. It's no good if nobody uses it. It's just me talking at a whiteboard. Millions of people use Cardano. Tens of millions of people use Ethereum. Hundreds of millions of people use Bitcoin. They reach scale and adoption. That's awesome. So how do you launch a cryptocurrency in 2025? How do you get to a scale of millions to billions of users? How do you do that? So here's the wrong way. Ponzonomics, also known as the VC special. Some group of founders has some great technology. They go to a venture capital, they go to some crypto investor, they create an insider distribution of tokens. They get the exchanges on board, they get the market makers on board, and all these other insider actors. They launch the token, they pump it up, the retail people see it, they say, oh my gosh, it's going to the moon, and then they exit. Oh, no, sad, bad. This is the story of more than 20,000 cryptocurrencies. That's the world we live in. This is why cryptocurrency has a bad name, the Ponzonomics. The other thing, too, is they introduced this thinking. It's called sum zero. So they say, well, we will win. We will be the future. How will you win? Where will you get your customers from? Well, all the Ethereum people will leave Ethereum, and they'll come to our chain. Or all the Bitcoin people will leave Bitcoin, and they'll come to our chain. Or all the Solana people will leave Solana, come to our chain. And we'll spend billions of dollars that we've raised from that insider VC special Ponzonomics, and we'll spend it on AstroTurf marketing, and we'll get lots of people, including celebrities and sports stars and Dave Portnoy and all these other people, just come on in and have some fun. And then they'll complain when it goes here. And then we'll do it again. But this time it'll be different. Trust us, like a politician. Do we do that? No! That's bad. That's wrong. We're going to do it cooperatively. So the first step is the glacier drop. We thought for years, how do we build a mechanism to bring everybody together and just give it away and let everybody have a piece of it, everybody have a distribution in it? So what we did is design a system and that system airdropped to 8 different ecosystems, and they were all very, very different. 7 blockchains. And some are more business-oriented, and some are more exchange-oriented, and some are more retail-oriented, and some are value. And we also got the core 3, the first generations. Bitcoin, Ethereum, and Cardano. But then also Solana, Binance Smart Chain. We got Avalanche, XRP, and we got BATS, the basic attention token, because advertising is such a powerful thing. So we brought all these ecosystems together, and we created the largest airdrop ever done. And we're in the middle of it right now. 33.6 million accounts were eligible, and people just could claim. And over time, it thaws, kind of like a glacier thaws. Are we done? No, because there's also this proof of work side of the world. And if people don't claim what was allocated, well then, what if they can scavenge or mine what's left over? So we set aside 21 days for people to mine. And already, there's so many CPUs on this, this has consumed more computational resources than the first few years of Bitcoin, to give you a sense of how much participation. And then if you didn't participate, you didn't care, at the end, there's also a lost and found. And the lost and found, it's kind of like that guy who had the Bitcoin and he threw it away. And then he spent the next 10 years running around trying to get it out of the landfill because it's worth $200 million. We put in the Genesis block of midnight the ability to claim your stuff you didn't claim in your glacier drop. So these three things together, what they do is they create a fair distribution. Right of first refusal for all the tokens to everyone everywhere. And that's the very first step because it gets rid of the Ponzonomics, gets rid of the VC special. No one has privileged access. Everybody has equal access. And also, these ecosystems represent the totality of all cryptocurrency. They represent more than 95% of all the value in the cryptocurrency space, 95% of all the transactions in the crypto space, and more than 500 million users between all of them combined. And all the major utilities of the cryptocurrency space are represented here. So step one is create a distribution that's fair. That's the first step in getting rid of the Ponzonomics, killing the Ponzonomics. But we have to do a lot more. There's always more. Second, having been in the space for 15 years, I've seen every tokenomics that you can ever see. And the thing is that there's these two things that tug at each other if you want to be a useful cooperative ecosystem. One is the deflation. This is the Bitcoin special. Bitcoin, its key USP is there's a belief amongst the people who hold it, because it's deflationary, that over time it appreciates in value. The opposite of the US dollar. If you hold the US dollar and you look at a chart of the US dollar from 1913 to today, it's only worth like 3 cents of what it was worth in 1913. That's inflationary monetary policy. Deflationary policy, like gold, it tends to go up over time. Why? Because demand increases relative to supply. That's awesome. And so deflation is something people really care about. It's what made Bitcoin Bitcoin today. It's what made us a multi-trillion-dollar ecosystem. But the problem with deflation and speculation is that if you're a useful system to run agents, a useful system to run medical records, a useful system to do real things, you don't want a situation where your prices do this. It's pretty consistent, and then it's way high, and then it goes way down, and then it's kind of consistent, and then it goes way up, and then it goes way down. You don't want unpredictable pricing. So how do you get predictable pricing? If I'm building a web application, if I am building a business, I need to know what the price of my services are, day to day, week to week, month to month. So if I have a speculative deflationary thing, over time it goes up, but it's unpredictable, which is why crypto has had such remarkable shocks. We have seen tokens go up a 10x and down 90% within 18 months, and go back up a 10x within 24 months. I can't build a business if I can't project out my cost of goods and services. So what if you had a dual tokenomics? You had one deflationary asset, we call this Knight, and that asset represents the ownership, the governance, and the consensus control of the system. So it manages the ledger, very much like ADA does with Cardano. But you have another asset, and that asset represents the computation of the system. And one generates the other. And the generation function can vary over time to promote predictability inside the price. What this also allows you to do in a public and private system is you can have one asset that's public and you can have one asset that's private. This separation conceptually and this separation technologically also means that you can run these on separate networks. So you can launch with one on a safe network, in this case Cardano, which has been running 24 hours a day, 7 days a week, never goes down, never been hacked. It's pretty reliable. People like it. You should check it out. The other one can run on a new network. And this new network can be experimental and changing all the time and doing all kinds of weird things and have different monetary policy. And if something happens, heaven forbid, it doesn't compromise the stored value of the system. This is the magic of it. And there's something really cool that you get to do next. Okay? So step one is have a fair distribution. Step two is have a dual token model and have one be deflationary and the other one promote predictability in terms of price. One be public, which is listing friendly. One be private, which preserves the freedom of association, commerce, and expression of humanity. But there's one final thing we have to do for cooperative economics to make sense. So far, we've distributed a token. So far, we have a novel monetary policy, but we haven't solved that sticky problem of network effect. Bitcoin maxis don't want to leave Bitcoin. Ethereum people don't want to leave Ethereum. Solana people don't want to leave Solana. Maybe they do, I don't know. Cardano people don't want to leave Cardano. I know that much. They like Cardano. It's happy. It's warmth inside. It's joy. So the question is, how do you have a hybrid application? It turns out, when we were talking about rational privacy, and we talked about this on-chain and off-chain could be another chain. So if you build your infrastructure in just the right way, you actually have the ability for people to build applications that live on Ethereum, and they consume Ether, but they also live on Midnight, with a unified state management and DevX and all these other things. But how do I pay an Ether for a different network? Well, you have this concept of a capacity exchange. A capacity exchange. So Dust sits here. It's this nice little private thing. Night generates it. And then people show up and they say, I got some Ether. I'm on Uniswap and I want to go through that KYC step. They pay an Ether. The capacity exchange swaps it. And the Dust pays the transaction fee, and the holder of the Dust gets the Ether. Same for Bitcoin, same for Sol, same for ADA, or any other asset. It's a marketplace for all these assets. Very specialized kind that's intrinsically private at its core and transactional at its core. And what it allows you to do is to create predictable pricing, but more importantly, it also allows people to consume in the network of their choice. It doesn't matter if they have a stable coin. It doesn't matter if they have a cryptocurrency. They come, the exchange finds a way to match it, and this allows them to basically pay the fees. And if you build your hybrid state the right way, when Ethereum looks into Midnight, it feels like an extension of Ethereum. When Bitcoin looks into Midnight, it feels like an extension of Bitcoin. And you say, well, Charles, how can this be trustless? Well, if I have these proofs that allow us to do selective disclosure of people, what if I could do selective disclosure of a blockchain? So there's this property called folding. It's super cool. It's in the zero knowledge space. It's pretty magical. What if I take the entire history of the entire blockchain, everything that's ever happened since the beginning of time with it, and I create a proof of that chain? And what if that proof is really small and easy to validate? And what if Midnight could do this? What if Midnight was directly observing multiple systems? What if Midnight was doing that? Well, then I have a proof of the entire network of Ethereum, and I have a proof of the entire network of Midnight, and we understand each other. So actually, we, through one transaction, can understand both networks, or any networks for that matter. So in essence, Midnight is kind of a universal observation layer that allows you to prove properties of all the chains that it touches using its folding engine. And because of that, this allows you to trustlessly, without a bridge, talk to these systems. It's pretty magical when you think about it, because at the end of the day then, you don't really care as an Ethereum user where things happen, how things happen. It just works. It's just magic. And you don't really care if you're paying an Ether or Bitcoin or Sol or ADA or any of these other things. It's like tourism. You go to Bermuda, you buy something. I pay in dollars. They get paid in their currency. I don't feel it. My credit card company handles that. Midnight handles that. That's the magic of cooperative economics. Don't make people care about the underlying network. Don't make people care about the state of their system. It's got to be trustless all the way through. It has to be inclusively accountable all the way through. It has to preserve what Bitcoin preserved all the way through. So are we done? Almost. Got more to do. So cooperative economics, fair distribution, dual tokenomics. We have this concept of capacity exchange. Well, there's two more things we have to do to truly bring in the cooperative economics. I've been in the space long enough. to see the wars of proof of work and proof of stake and proof of X. Everybody has their favorite algorithm. It's almost a holy war. So which is better, proof of stake or proof of work? Proof of stake or proof of work? Proof of stake or proof of work? You getting it? What if we just put them together? What if we put arbitrary consensus algorithms together? What if we have multi-resource consensus? What if, instead of paying block rewards to just one network, I play block rewards to all those 8 networks that I did a drop to, and every one of them does a slightly different thing. Some bring the computation, and some bring the user count, and some bring always-on validators and all kinds of things. Everybody can bring something to the table. So guess what we created? We created Minotaur. This is one of our most incredible pieces of technology. We co-authored it with the guys who created Eigenlayer. We created Midnight. They created Eigenlayer. I think we got the better part of the deal. That's okay. We like them. Multi-resource consensus. What if you could pay block fees, block rewards to multiple validators across different networks? Then all of a sudden you can mix and match the properties of each so you get all the benefits. There are things that proof of stake does super well. There are things that proof of work does super well. And instead of trying to go to war with each other, why don't we just all work together cooperatively? It's not just the economics, it's cooperative consensus. Let's put that together. Let's work together with that. That's Minotaur in a nutshell. And this is another one of the hearts of Midnight. Nightstream, Minotaur, capacity exchange. They all start coming together. So suddenly you have validators from every network. If you have validators from every network, everybody is watching each other's chains. So then if I can create state proofs for every network, I can also do lightweight consensus, log space consensus. So for the first time ever in the history of the space, you don't need to have a full node for every chain that you're doing consensus over, just the tip of it. So it's infinitely scalable. We can add thousands, eventually millions of different chains if we really wanted to, and spread out those block rewards and spread out those capacity exchange fees, and everybody gets a piece of it because it's cooperative. That's the key, cooperative economics. Okay, so we have the capacity exchange, we have multi-resource consensus, we have dual tokenomics. So are we done? Have we finished? Have we reached the promised land? No, we have not reached the promised land. We also have intention. Intention. And this is the capstone of the pyramid. Everything that we've built leads to this destination if we've done it right. It's the very top. You don't use cryptocurrencies for the sake of using cryptocurrencies. You use them because there's something you want from them. They're infrastructure. You don't go on the internet and say, oh, I'm on the internet. I've arrived. The internet's here. I cannot believe I'm on the internet. Maybe there's some weirdo there. I don't know. Most people are like, I got to go to Amazon and buy something. I got to go to Facebook and chat with my mom. I got to go to TikTok. I got to go to Tinder and do a thing. They go somewhere for a reason. There's an intention behind what they do. There's a why behind what they do. The problem with cryptocurrencies, and I'll explain this, is they live in procedural land. Procedural land. Okay. And to explain this concept of declarative versus procedural, imagine navigating. I say, all right, there's 2 ways I can tell you. Go ahead and go to Applebee's in Broomfield. You know where it's at? Yeah, I know where it's at. Great. Be there at 12. My intention is to have you show up at a place at a time. Notice something. In the instructions, I didn't tell you any of the details on how to get there and any of the details of what to use to get there. You can go on a bicycle. You can go in a car. You can travel in a helicopter if you want to. You could walk. You could be on the back of a llama. Doesn't really matter. I just say you have to show up at a place at a certain time. That is declarative. And that's how most of the world works. I want to be a doctor. I want to be a lawyer. I want to be a mathematician. I want to be a millionaire. You have an intention. You declare the intention, and then you got to figure it out. And that's kind of your business. But cryptocurrencies, they live in procedural land for the most part. So instead of saying, I want you to meet you at Applebee's at 12, you say, all right, get into a Ford Fusion with exactly 50% fuel, drive down this route, go at this speed, stop at this sign, restart the car, drive again, stop at this sign, restart the car, drive again, step by step by step by step. That's what transactions and smart contracts look like. That's not life, but that's the cryptocurrency. That's the smart contract. So when we think about the 21st century usage of the cryptocurrency space, what's going to happen is we're going to move from transactions and smart contracts to intentions, to intents, and the world will become declarative. Well, the minute that happens, are we really saying settle on Bitcoin, settle on Cardano, settle on Ethereum, settle on Solana? No, we're saying buy $200 worth of snack at any price below X by tomorrow. Who's going to fill that? That's your intention. Does that settle on midnight? Does that settle on Cardano? Does that settle on Solana? Well, SNEC is a Cardano asset, probably settles on Cardano. But what if SNEC is now listed on a Solana DEX? What if SNEC is listed on Kraken? And you can buy it from a SEX, a centralized exchange, instead of a DEX. Where does it go? Who decides that? You're just like, below X, buy tomorrow. You have a time, you have a price, you have an amount, you have an asset. This is your intention. So the problem with intention is, if I know your intention in a global, transparent, audible sense, I may be able to manipulate that, because you say below X, well, your X might be, I don't know, $10 a unit. So I can fill that intention at $9.99. Well, what if the market is only $1? Because I know your intention, I can front run you and just maximize the price and screw you. So you want not just intention, but you want fair intentions. You want trustless intentions. You want intentions that represent your best interest. You want the ability for the network to do things in a way that it maximizes what you care about, whether it be security or cost or privacy. Thus, any layer that has intentions has to have rational privacy at its core. It has to know that. Because otherwise, everybody in the world knows your intention, and then everybody in the world can background engineer it in the least favorable, least fair, least trustless way. Also, by revealing your intentions, it may create compromises. For example, if you reveal that you want to pull all your medical records, and you reveal that you've checked your life insurance policy, and you reveal that you've decided to take an unexpected trip down to MD Anderson, and you reveal that you've canceled all of your future travel for the next 6 months to a year, a lot of people can infer from that that you probably have cancer. Do you want people to know that? If you put all these intentions in a public system, they do forever, and AI will use that against you. It's the Miranda rights of the future. Everything can and will be used against you. So you need a layer for intentions. You need a layer for commercial intentions to exist, and they have to paradoxically be programmable and decidable, deterministic, but at the same time, intentions also have to be private. They have to have rational privacy. Well, here's the beautiful thing about Midnight and what makes it so special, and it really ties the Lebowski rug together, the cooperative economics of it. Intention on Midnight is best. Why? Because Midnight is a layer 2 to everybody, which means if it can understand all the systems it touches, improve trustlessly the properties of those systems, and add privacy to those systems, it's the only fair arbitrator of intention. It can be the intention layer of the entire internet. You send it to Midnight, and Midnight will figure out how to route it. Maybe it's best on Ethereum. Maybe it's best on Solana. Maybe it's best on Bitcoin. You are in the driver's seat, and trustlessly Midnight can figure that all out, and none of these networks know. They don't see. They don't hear, they don't taste, they don't touch, they don't feel, that type of stuff. And because of multi-resource consensus, it's trustless and transparent. And magically, that dual tokenomics means that your intention is always predictable in terms of its pricing. You pay in any resource that you want. And you know what? It's fairly distributed. So that means the network belongs to everybody, not the VCs. There's no Ponzonomics. So that, my friend, is cooperative economics. So that's the fourth generation. Cardano doesn't have it. Ethereum doesn't have it. Solana doesn't have it. If they say it, they're lying. Trust me, I spent years building it. And we thought really carefully about all these things. We thought about rational privacy. We thought very carefully about identity. And we thought very carefully about cooperation. We spent 6+ years of our life, hundreds of millions of dollars, and we just gave it all away. Why? Because we need it. If you want your freedom of association, commerce, and expression, and you want to rewrite the economic, political, and social systems of the world, you need infrastructure that's capable of doing that. In the coming months, as the network comes out, and the coming years as everything turns on and all this magic turns on, we can scale to billions of users using that magic hardware that NVIDIA builds and all these other people do. And we can take the best cryptography and ensure that your human rights are protected. And my dream is that we'll be able to run your economy, your political systems, and your social life in a way where you're in charge. The reality of what we've built here is that we live in a future with liberty, and we live in a future where you have economic agency. We all lived through COVID. We've all lived through economic collapse. We've all lived in times where our freedom of movement has been compromised. Our ability to express ourselves has been compromised. Our belief in political systems is badly broken. And frankly speaking, our money systems suck. $37 trillion of national debt in the United States, headed north to 50 soon. Your money's becoming worthless. And you're told to just be obedient, get in the corner, accept it, and continue to hand more power to the trillionaires. These big companies. And don't worry, they have your best interest at heart until they don't, and then you have no agency to express what's happened. I don't want to live in that world. I don't think you want to live in that world. And to get to a world that you don't have those properties, you have to think very carefully about how not to hand it over to the vampires. And you have to think very carefully about how to get everybody cooperating with each other. Midnight is our best attempt to try to bring 15 years worth of lessons from my time in the cryptocurrency space and the hundreds of scientists and engineers we've worked with and the other ecosystems we've worked with together. Every piece of it came from some innovation, some in-house and some others. We didn't invent the DID, but damn it, we're going to refine it. We didn't invent lattice-based cryptography, but we're going to take it to its logical conclusion. We didn't build the hundreds of billions of dollars of data centers for AI, but we're sure as hell going to take advantage of them and bring the big people in. But you know what? If it's fair, everybody plays by the same set of rules. There's an equality there. The least amongst us has the same access as the greatest. That is a foundational principle that I can live by. So thank you so much for listening about Midnight, the fourth generation. It's coming soon to an exchange, to a wallet, to a node near you. It's been a long road. I'm a little older, I'm a little fatter. It's been 8 years since I had a chance to do a whiteboard video like this. But I haven't lost my passion, and I still love what I do. It's the honor of a lifetime to be able to watch all of you live out your dreams and build cool things. Back when I joined Bitcoin, it was just all aspirational. And then when we did Ethereum and Cardano, we actually saw something significant. And there's all these new generations that are coming. But we're not done yet. We're not ready for everything to live in the blockchain. We still have TradFi. And we still have DeFi. And you know what? With Midnight, we're just going to have Fi. As long as it's fair. You can't violate the principles that got us here and shortcut hard work. Everything takes hard work. It took us 6 years to conceive of this and get it to market, and we'll be working on it long afterwards, like the 10 years we've been working on Cardano and the 8 years it's been running. And we'll keep doing it because I want to live in this world, and I think you do too. Thank you all for listening, and have a wonderful night.